So for our first proper example of the semester, we want to graph the equation y equals the absolute value of x plus 1, where for a quick reminder on how absolute value functions work, they take whatever thing you put in and spit out the positive version. So these generally have sort of a V shape to them that we're going to see later, and if you put in something like -5, you would get back out +5 for the strict, just by itself, absolute value. Anyway, in our case, and really for any situation where we want to handle the graph of an equation, the graph of a function, what we do is, well, we just take some values and we see what happens with our equation. We get the solutions at those specific values of x and see what that would look like on a coordinate plane, then play a game of connect the dot, where for this we're going to go from -4 to 2 because, well, we got to go from somewhere, and that's pretty representative. We're going to see it's pretty representative because, well, I know where this is going. Anyway, we're going to look at x equals -4, where at -4 we would be plugging in -4 into that absolute value. You'd get -4 plus 1 is -3. Absolute value gets rid of the negative, you get 3. So your corresponding ordered pair at that location would be -4 for the x value, 3 for the y value. Then we're going to go to -3. Technically speaking, you could pick anything from there, but I'm going to pick -3 because it's generally good form. It's generally easiest when you're dealing with a function like this, something that's almost a polynomial, which again, a word you should have some sense of, but we're going to talk more about later. When you have something like that, usually we like to deal with things in terms of nice, round integers. Anyway, -3, we plug that in, we get -3 plus 1 is -2, absolute value it, and you get 2. Then at -2, you take, excuse me, I should specify the ordered pair as well. From that last one, you'd be at the point -3, 2. Anyway, sorry. At -2, you would then take the value -2, add 1, you get -1, absolute value makes that 1, and you end up at the point -2, 1. Then for -1, plug that in there, -1 plus 1 is 0, absolute value of 0 happens to remain 0. Isn't that convenient? And once you have that, -1, 0, you then move, -1, 0, sorry, I'm getting ahead of myself. You move on to 0, where 0 plus 1 is 1, and then at that point the absolute value doesn't really matter very much because the absolute value of an already positive thing does nothing. It just stays 1. So you have the point 0, 1. Then at 1, 1 plus 1 is 2, absolute value of 2 is 2, so you have the point 1, 2. And then finally at 2, you plug in 2, get absolute value of 3 is 3, 2, 3, and you take those points. And like I said, we don't want to put too much faith in my ability as an artist. I'm going to let the internet do this one for me. You take those, you plot them all out, and when you have your points plotted, then, like I said, play a little bit, connect the dot, draw that between them, which, like I said, is a rough V shape. And it's not always going to be a rough V shape, but that is how you handle graphing for something you're uncertain of. You just make some points for yourself, see what you think it should do, and then draw a rough sketch through them. The purpose of graphing, as much as anything, is to be able to understand in a rough but not necessarily perfect sense what your equation is going about to do and what it could do elsewhere, just to get a better sense of what the pieces you're working with are going to behave like. And the next thing we'll look at is locations that correspond to very specific important behavior. We're going to see things called intercepts.